Hey there, in this video we are going to be generating random values using Numpy. More specifically, from numpy.random we are going to import the choice function. So we're going to get started by just providing the choice function with one argument, in this case 11, and what this is going to do is generate a random integer between 0 and 10. And notice each time I run the cell, a new random integer is generated. Now I could provide a second argument, in this case 20, and we see here that 20 random integers between 0 and 10 have been produced, and I'll jack it up to 50 just so that you can see those 10s were produced and zeros and all the integers in between. Now I'm just going to now show you that this object has a type of NumPy array. So if you'd like and you feel more comfortable with working with list, you can change this into a list object, and then you can make use of list methods such as the count method and count the number of 10s randomly generated there. And we see there were 3. Okay, so let's back that up a little bit. And I'm just going to generate this, and maybe we don't need so many values, so I'm going to choose 10 here. Now notice the values in this list or array change every time that I run the cell. So it would be really nice if we could make the randomly generated values predictable. And we can do that from numpy.random importing the seed function. So the seed function has an argument, and this number, 42 in this case, is going to be used to generate our random values. So now if I go back and run the cell, it generates random values, but they're all the same elements. If I change it to 41, I get new elements that are randomly generated. Back to 42, I'm back to the original 10 randomly generated values that are the same. So let's create a list here called students. So maybe I for I in range 1 to 33. So maybe my class has 32 students in it, and I want to get them into a random order. So I'm just going to show you here, there are my 32 students, and I want them in a random order. So now we can go back to our choice function, and the first argument is going to be our list, which is students, so our 32 students, and in this case we want to choose 32 of those. So we're going to generate 32 random values. Now let's go ahead and run this, and we get a problem because we see there's at least one value. I see a 21 here produced at least twice, and we can't have that. So what we can do is provide a third argument where replace is set equal to false. And this ensures that we get a unique array of randomly generated values 1 through 32. All right, we can take a look at another example here, and maybe this time we are going to have a list of even numbers. So I'm going to set evens equal to a list, and we'll just generate some here. So 2 times I for I in range 1 to 6, and then we can just call that and see what it looks like. So evens, and we should call out our choice function. So there's our list, and what we want to do this time is randomly generate some values from this list. So I'm going to have to change that first argument from students to evens, and maybe this time we will choose 3 values, and for 10 and 6, and again replace was set equal to false, so we will get no duplicate entries there. So one last example, maybe I have some sample space set where the outcomes are heads or tails, and I want to choose from this set S, and maybe I want to choose 50 of them, but I have to set replace back to true. I cannot have this argument there because there are only 2 objects to choose from. And you can see here that I've generated 50 randomly generated possible values of heads or tails. Now I am going to turn this into a list, and I'm then going to provide a third argument to the choice function. And here I can set the probabilities of each of the outcomes to whatever I want. So maybe it's 0.8 for heads and 0.2 for tails. And this should ensure that the probability that a heads is tossed is much more likely than a tails. And whoa, that's really cool. We got 42, the same as our random seed. So 42 out of 50 are heads. So heads are dominating in terms of outcomes. So there's a very quick look at generating some random values using NumPy.